Join the class now. Okay, I'm waiting for you guys to join the class. Everyone start joining the class. Okay, so everyone should start joining the class now. We're about to start the class. Once it gets to the time, we'll start the class. Wait for others to join the class. Okay, start joining the class now. If you can hear me, just say you can hear me. You can hear me, say you can hear me. Hear me. Everyone start joining the class. Please invite your friends so that they can join the class. Now I can say only one person there. Only one person. Okay. So I'm only seeing one person in this class. I'm only seeing one person in this class. So we are looking at our chemical equilibrium. This is only one person. Then we can't continue this class more seriously because yeah, I'm only seeing one person in this class. It means that this class might not hold. Okay. Other people are joining the class now. So if you can hear me, leave a comment section that you can hear me. We are three now, but other participants, please give this video a like. Give this video a like, please. Give this video a like. It's very important. Please give this video a like. So now we'll continue with class. Other people will join class as we move on. So we are seeing what chemical equilibrium. This is where we started yesterday. This is going to be the part 2 of the class we started yesterday. Please, if you can see the board, tell me that you can see the board. Can you see the board? If you can see the board, tell me that you can see the board. Can you see the board? Those who are joining us, can you see the board? Please, can you see the board? Okay. So we commence with the class. The other people will try to join us. Just and we cannot wait again. We can't wait again. Other people will join us. So yesterday, now for the part 1 of this class here, I taught you we did writing equilibrium constant expression. It's okay, we did what? Writing equilibrium constant what expression? Writing equilibrium constant expression. That's what we did yesterday. In the part 1 of this class, it's okay. Write equilibrium constant what expression. That's what we did yesterday. That was the class that what we did yesterday. Now in this class here, you have to take what further. You have to look at what some calculation. So let's take some question. So now let's take some question. So question one for today. Question one for today. Write write the equilibrium. Write the equilibrium constant expression Kc and K for each of the reaction. For each of the what reaction. Now, after teaching, so yeah, move it to what calculation. It's okay. Move it to calculation. So write the following constant expression Kc and Kp for each of the what? For each of the reaction. So here we have the first one here. A. Here we have PCl5 gas giving you PCl3 gas plus Cl2 gas. It's okay. They are B CaCO3 solid. Then you have this one here, CaO solid plus CO2 gas. Then you have this one here, C NH4Cl, NH4Cl solid, and you have NH3 gas plus HCl what gas. So this is what you are starting with. It's okay. So this is what you are starting here. So please take it down. So it is the solution, right? The equilibrium constant expression Kc and Kp for the each of what follow what reaction. So here we have this one here, the first one. Here we have the second one, and here we have what the third one. Just here we have what the third one here. So now let's start writing this one here because after this one here, we move to the calculation aspect. We move down into what to the calculation aspect. So you take it down. Now, when you write the equilibrium constant expression, when you write the equilibrium constant expression here, there are societies you need to take note of. There are societies you need to take note of here. Note. When you write the equilibrium constant expression, when writing equilibrium constant expression, the concentration of gas and aqueous are used, the concentration of gas and aqueous are used. It's okay, are what are used. But the concentration, but the concentration of liquids and solid is equal to what? To 1. It's okay. So now, when you write the equilibrium constant expression here, you have to take note of what this one here. When you write the equilibrium constant expression, the concentration of gas and aqueous are used, but the concentration of liquids and solids is equal to what? To 1. So you want to pay close attention to this here. It's very important. So you have to take it down. It's okay. Take it down. So with this understanding here, let's write the equilibrium constant expression for this what reaction. Let's write equilibrium constant expression for what this reaction, because after this one now move to the calculation aspect, which is very, very important. And is the calculation aspect I really want to do up today. Please can you see the board? If you can see the board, just say you can see the board so I can continue. Okay. Now remember, if I ask like this, A, we should say A gas plus B giving you C. Now let us say let's write the equilibrium constant expression for this reaction here. It's okay. Let's write the equilibrium constant for equilibrium constant expression for this reaction here. So it's going to be Kc. Now what is Kc? Kc means what? Equilibrium constant expression for what? In terms of concentration. It's okay. Equilibrium constant expression in terms of what? Of concentration. That is meaning. So it's equal to what? Concentration of the products raised by what? Coefficients. What? Concentration of the reactants raised by what? Coefficients. It's okay. Now, this square bracket means what? Concentration. It's okay. This square bracket means what? Concentration. So now, here we have the product here. What is product? The product is what? It's C. It's okay. The product is what? It's C. So let it be Kc equals to what? Concentration of C raised by what? C over what? Concentration of what? Of A raised by what? A. Then concentration of what? Of B raised by what? 1. You remember here is 1, right? 1. So this is what you're going to use when writing equilibrium constant what? Expression. Do you understand? So we have to take this one here, this and this. Now let's start writing the equilibrium constant expression for this what reaction here. It's very important. So takes it down so that you can start writing equilibrium constant expression for this one. Then before we move to the next part of this class, which is what calculation aspect, which we have to look at very well. The calculation aspects. So you have to take some down. So let's take this first one here. Here we have PCl5, right? Gas. We now have what? PCl3 gas plus what? Cl2 what? Gas. It's okay. Now let's try the equilibrium constant expression for this reaction here. It's okay. So if you check very well, one atom of phosphorus here, 1 atom of phosphorus here, 5 atom of chlorine, 5, 3 here, 2 here, so it's balanced. So when an equation is being given to you to what the equilibrium constant expression, one thing you want to know is to see if the equation is balanced. Just so if the equation is balanced, then we cannot move on. So now let's try the equilibrium constant expression now. Going to be what? Kc equals to what? Here we have what? Our product, right? So going to be concentration of product Cl3 gas. Remember here is 1, so you can say this by 1. It's okay. Then concentration of Cl2 gas. This by what? 1. Is it clear? Over concentration of PCl5 gas. This by what? 1. It's okay. Now remember, there's no point of putting 1 here, so I can ignore what my 1. It's okay. I can ignore what my 1. Okay, start. Now, remember that concentration of solid and gas are not used, right? But gas and aqueous are used. All of them are what? Gas. So we don't have issues here. Do you understand? So these are the Kc expression for this what reaction. Now let's look at what the second reaction here. Here we have CaCO3 solid. Then you have this one CaO solid plus what? CO2 what? Gas. Now remember here we have solid, and what? Gas, right? So how do you write the Kc expression for what? This reaction? How do you write the Kc expression for what? This reaction? It's very easy. So normally it's supposed to be like this, right? So it's going to be Kc equals to what? Concentration of CaO solid, right? This one, but they don't put the 1 here, so I can ignore it. Then concentration of what CO2 gas. This one what one, right? But then put the one here. All over what concentration of what CaCO3 what solid. This one what one. This is that. But understand that when writing equilibrium constant expression, what you want to know here is that concentration of solid are always equal to what one. This is what you want to pay close attention to. Concentration of solid is always equal to what? One. So this guy going to be one. Why this one to CaCO3 is what is one. So what I want to do here is that anywhere I see all this place here, I'll put what one. It's okay. I'll place one inside. So if I should write that here, let me just write this place out. So if I should place what to be one, so here I'm going to have Kc equals to what? One times we have CO2 gas over what? One here. It's okay. So they don't want to put it one, say yeah. So can you just ignore this one here? So going to be Kc equals to what? Concentration of CO2 gas. That is it. So the equilibrium constant expression for this reaction is this. This is this guy here. As easy as that. So you also use the same approach here to write the equilibrium constant expression for this what reaction. You have ammonium chloride broke it down to form what ammonia and what hydrogen what chloride, right? So the way here to what solve to write the equilibrium constant what expression. Please, can you guys see the board? The screen is not clear. Seriously, can't see. Probably it's network. Network is really affecting our class. Network is affecting the class. Can you see the board? So we are done with this one here. We are done with this here. We are done with this. Now let's enter this place here. Let's enter this one. Let's write the equilibrium constant expression for what? For this what C part. So if you are following what I've done here, you should be able to answer this one yourself. But now let's do it together. NH3 gas plus HN gas, right? So now let's try the equilibrium constant expression for what for this what reaction here. So this is already balanced. The question is what is already what NH3 so gas, right? And you have what HCl what gas, right? Over here you have NH4Cl solid, right? Now, but understand that solid is not used. So because concentration of what NH4Cl is equal to what one because what is solid. So that is my Kc is going to be what NH3 gas. Then you have what ACl what gas. So that is it. You understand? So we are done writing the equilibrium constant expression for what this what reactions. We are done writing the equilibrium constant for what this what reaction. So the next one to do here is so calculation of what equilibrium constant. That is what going to be the what next thing. That's going to be what the next thing. Calculation. calculation calculation of equilibrium constants. Calculation of what of equilibrium constant. That is what the next we are going to look at.